This is the ground reality of the sewage treatment plants. As published by CPCB, out of 1,200 plants, nearly 10% are defunct. These are random site visits across the country, and rest of them, almost 77%, are non-compliant. It's a very known fact that 80% systems are not delivering the results. Just by merely seeing this, we understand the complexity of these systems. And the challenges are quite clear. Very rarely I have seen systems that are functioning beyond a 10-year period. I have seen systems that are working for 15 years, 18 years, but those are rare cases. The high energy bills are one of the biggest reason in the urban area where the apartment residents and villa residents, they are choosing to bypass the water because they're unable to bear these bills. And at the time when the builder builds this, some of the builders have done very good job. Not that they compromised on anything. They brought best systems and they installed them, but they never have understood what it takes to run these systems for 20, 30 years. Sludge handling, in many places they install screw press. I don't see them see it working. Most places. Order is a common phenomenon that you don't have to ask anybody for STP. It's just your nose is your GPS, it takes you there. Noise, there are many high-rise communities today in Hyderabad struggling with these noise issues that you're putting the systems in the basements and the noise is going all the way to 6th, 7th, 8th, 10th floors. And there are some systems that were replaced recently with the Prestige Group in Hyderabad, at least about 3 projects, because of the noise levels. But the rest of the things are pretty straightforward. The reasons and challenges, what I found, this is out of my personal experience, is thus what I mentioned, understanding the life cycle cost, that you invest a crore on an STP, thinking that you got the problem solved, but we actually created a problem there. A crore of investment, now you have to have 5 to 10 crore rupees to operate it for 10 to 15 years. This is the kind of life cycle cost we are seeing with systems. Contractor margin, wherever there's L1 business, they're compromising on something, and the result is what I mentioned below, very high cost on the environment. Number of drives in operating system are high. There are not many institutes that are training manpower on how to operate STPs. So this is adding to the complexity of the problem that is out there. Most people are getting trained on the job under a supervisor. So the guy who is getting trained gets as good as the supervisor is. And this is the scenario all over the place. And revenue models for recycled water as a major challenge today in India. In Telangana, we are struggling with this. Government has announced free water. So very few respect the water. The alternatives that I'm talking about are these. A few minutes ago, we have seen that other image. And these are the systems that we are building. These are complete replacement of the conventional systems. They're built in different sizes. This is built right next to the bedrooms and balconies, hardly 3 meters away. And many of them who are coming newly into these buildings, they don't even know that it's an STP. So this is how these systems are. The technology that we are using here, because it would be easy for us to relate to the conversations, this is exactly what we are doing in all the commercial projects, whether it's sewage treatment plants or effluent treatment plants. This is a nature-based solution, but we have augmented it through introduction of this 4-bed aeration, that we release micro aeration at the bottom of the wetland, which is only about 8 hours a day, using very minimal energy compared to a conventional system. But this delivers great deal of results when it comes to removal of nitrogen, ammonical nitrates, which is what is mandated today for surface discharge. So the entire science is hidden from the user. The user only sees just this. This is what the operator has to deal with, just housekeeping of these plants, probably adding some bacteria, and nothing more than that. When the science, entire designing, engineering is done here, so this is implemented in this fashion. These systems run for 30 years with all the bells and whistles that how do you maintain the system in the event of any clogging scenario, if something is going wrong. We provide all kinds of access points where the system can be very easily maintained with low-skilled, under-skilled people. And these systems are capable of handling loads, very high loads. BOD, you can go up to 1,000, 2,000, whatever required. The footprint changes. We have proposed these systems to treat big waste where nitrogen levels are in 1,000 or more than that, and BOD levels are 1,500 above that. Sewage is less of a problem for these systems. A lot of mining projects are handled in US and other places. The mining wastewaters were handled through this technology. It's very known that, this is what I'm referring to. Passive wetlands used to take a lot of space. Then we started to dose certain bacteria ahead of time into the holding tank, where the biological activity starts to happen faster. We were able to reduce the land footprint to 2.5 square meters, which was also not enough reduction for urban areas. So we went into aerated wetlands. We brought the size down to 1 square meter per KL today. So we build the least footprint wetlands in India as of today, and we are further augmenting the passive holding tank, the holding tank that we have in this. The water comes into this holding tank. It's pumped basically, or it comes by gravity. This is a passive system. We don't do anything here except adding certain bacteria. Now we are trying to do something within this holding tank where we can further reduce this footprint of the wetlands, where footprint is a challenge. If the land is available, I would like to minimize the energy and minimize anything else and have as big a wetland as possible, because these are more robust and more sustainable. So this is a treated water that is coming out of a 1.2 MLD treatment plant installed for Deccan Cements. Just to give a visual presentation of how a system looks, what we built. So all these pipes are coming from the bottom. There are access points to reach out to the bottom if something were to go wrong. So this is just built in a 3.5 meter setback that was given to us out of their 6 meter setback that they had. There's a holding tank that was built prior underground. From there, the water gets pumped single stage into this wetland. There are 2 wetlands in this one. And entire water is a subsurface water that you don't see water outside. Anytime you expose the water, like in SBR, MBBRs, anytime the water is exposed to ambient air, anytime wind blows over it, you would certainly know where the STP is, because they carry the waters with that. Here, subsurface wetlands does not provide that kind of a challenge. This is all the machinery that we have. A very tiny blower, runs for 8 hours, controlled by this control panel, which is timer run. And we have set up a small ozonator for disinfection to take the water for dual plumbing, when you have a dual plumbing for flushing purposes. So that's all the STPs. And a conventional STP. This is a typical conventional STP. Not all STPs look the same, conventional ones. There can be much more cleaner ones, simpler ones, but average, you find a good number of pumps, blowers, motors. And the one ahead that you're seeing is a screw press, which I said rarely works. In this case also, it's not functional. So this science can be applied for many applications. Some of them are listed here. These are reasonably sludge-free, simple to operate, no odor, no noise. You can design them to fit into your landscaping needs. You can integrate them with your campuses. And if you have a very small footprint, you can actually go G+1 model or G+2 model. Once the engineering is figured out, the science can be taken to next levels in any fashion. These kind of systems bring character to the spaces. We build these systems actually in the same fashion. A lot of visitors actually do surprised to see that their treatment systems. These are some of the projects that we built. There are about 70 projects overall we have done, and we are building another 40 projects in the next 1.5 years. When I talked about life cycle cost, this is what we are talking about. A conventional system costing this with the energy, with the manpower, coming into 56 lakhs overall. Here we're talking about 24 versus 7, 20 versus 5, 8 versus 2. There is some cost here for the enzymes and bacteria that we use, but otherwise In this scenario, in 24 lakhs, there is zero money available for anybody, not to the contractor, not to the client. It's a direct money that is paid to the government. Contractor can make a little money here. If there are less repairs, he can make a little money here. In this one, there is not much money. So on a 56 lakhs burn, not anybody is making any money here. So what is the incentive for these fellows to really keep up with the quality that is required? So the business models have to be revisited, in terms of building systems. Life cycle cost, when you take it, it's a 15-year life cycle, assuming that the system works 15 years meticulously, which is not the case with most systems. You're talking about 15.53 crores for a mere 2.5 crore capital investment. You're talking about this 7.9 crores in our system. For a small 100 KLD community, you're talking about energy cost about 45,000, 47,000, manpower cost. And here 15 years for a 45 lakh, 100 KLD sewage system would cost about 3.2 crores. This is where small communities, the 100 families, 200 families, apartments, they are really struggling today to be able to meet this kind of monthly bill, which was not told to them. They're not aware of it. We can do a pretty holistic approach for a citywide design, which is what we can have a part of the discussion today on how we can integrate things with lakes and nalas and the STPs. And there's a huge advantage India has today, which to my knowledge, the government is not leveraging, or probably the right people are not taking things into their hands yet because of the limitations, whatever they may be. But we will cover this part in a detailed discussion. It significantly contributes to the SDGs, about 5 SDGs, but primarily I picked up climate action. We're talking about 80% less power. So you're talking about reduced carbon emissions, which otherwise are significantly high. I'm sure most of us here probably are aware of the fact that sewage treatment plants and effluent treatment plants contribute as the sixth largest factor to GHG emissions. The amount of methane that is getting released to anaerobic digestion and the kind of energy that is being deployed on treatment systems is humongous. In wetland system, they act as carbon sinks and provide the carbon sequestration. They bring the biodiversity to the game, and finally, they do serve the ecosystem restoration services. So when you go about environment sustainability and social governance goals, a lot of players are now looking at how do we reduce our energy consumption, in what way, and how do we bring rest of the things into the conservation. So these wetland systems can provide a great opportunity for us to redefine the wastewater treatment space. Not saying this is the only technology. There are a whole good number of technology that can be deployed, but we have been practicing this and we are seeing results significantly, and people are benefiting from it. There are some other projects that are listed out there. So this person, Paul Lu, has visited India and he was scouting for certain things. He wanted to run a Raj environmental program here. So someone told that there is a nature-based solution. So he came out to see this plant, 2.4 MLD, and he was taken by surprise that in India, this system, these high volume systems are being built. So he was telling that if this system is working in this corner in a village, it can work everywhere. He is saying that the main thing is to find the plants. Everything else is the engineering. So that was his opinion. And he was saying that he has visited so many sewage treatment plants across the world, and they say no smell. Even though people say no smell, there is always some smell. And in here, he didn't find any smell. So he was quite surprised with that. So that's what he was sharing with. Very likely, there will be a program that he'll be running in this campus, Kana Shantivanam, sometime in February. I'll share that with you all. So a lot of people ask, wetlands, what happens when it floods? Flooding, wetland and flooding, the concept is not right. When you're talking about constructed wetlands, we are talking about engineered systems. But here, unfortunately, when we built the system, when we designed the system, we got an FTL from the surveyor. And we went with that FTL, we designed the system. But after building the system, within a year, the huge rain and there's a flood came into this place. And we discovered that the FTL that we got from the record was not the FTL, actually FTL. The FTL is much lower, much higher. So the water came backwards. This system was under flooding for about a month. So a lot of people asked, what happens to your wetlands when it floods? Nothing happened. It flooded a lot of other places. It flooded this place also. After a month, the water receded and the wetland started to function again. After this, we have raised the bunds to map the FTL level so that any flood comes again, it doesn't damage the sewage treatment system. It doesn't damage, but when the flood comes, it can bring all the plastic kachra into the wetlands, which means you have to actually manually clean all of that. And probably the top layer of the gravel has to be examined for any deposits. Other than that, it doesn't disturb any of the engineering that we have done at the bottom of the wetland. None of the hydraulics are affected and nothing has been affected. So these are some of the things that I wanted to share today. So this part of uh, is the work that we do. This is the background I come from, and I do not know a lot of you here. You must be much experienced, and you may have a lot of things that you probably know.
Yes,
So
right.
this is my little work.